Given an equation of a parabola, graph the parabola using its focus, directrix, and vertex. Example 1, graph x squared equals 16y. So we go for the vertex. It's 0, 0. Why is that? Because the general form is x minus h and y minus k, but we don't have any of that in there. It's going to be 0. So the form is this form right here, 4py, that has vertex 0, 0. Parabola opens up. How do we know that? Because we look at the form and it's positive in front of the y. So it opens up because the square is on the x and the number in front of the y is positive. It's of this form, so and p is always positive, so it opens up. Another way you can realize is that y is equal to 1 over 4p x squared, and that's the normal kind of equation we have seen during the semester. So it opens up. Find p. Well, the form it's in is x squared equals 4py, and we have the 4p right there. So 4p equals 16, so p equals 4. P equals 4. Okay, now let's go down here. On this graph here, let's use all that information. Okay, we had the vertex at 0, 0. We had it opening up. So let's just lightly draw. This isn't the official version, but it just reminds me that it's opening up. And P is 4. So since it's opening up, the focus is inside the open up side. It's inside the parabola. So that's 4 up here. 4 counting away from the vertex. And the directrix is in the opposite direction. 1, 2, 3, 4 down here. So the directrix is down here, this line. Okay. That's y equals negative 4. That's the directrix. Now all we have to do, we got the focus at 0, 4. All we have to do is erase our guide here. That was just to get the orientation of where the directrix was in the focus. So now we're going to just graph the actual parabola by seeing a point maybe here where it's equidistant from the focus and the directrix. I'm just eyeballing this. I think that's about equal. Okay, and now I'm going to draw the parabola through that, and I'm going to use this symmetry to then draw it equal on the other side. So that's about 6, 2. That's not an official point on the parabola, but it's just for roughly graphing. So maybe I should just put an X there. Okay, so now we're going to draw through the parabola. Okay, and this is the curve that we get. Just a kind of a rough sketch. That's all we're going for here. We're not trying to plot a lot of points because we could have just done that at the beginning. We're just talking about using the directrix and the focus so that we eyeball a point where it's equidistant from here and here. And then, just for fun, I solved it for y and got this. I graphed that and got this as the answer, and that looks pretty darn good as equal to that. Now we're going to go down to another example. Example 2, y squared equals negative 8x. Vertex again is 0, 0 because x minus h is x minus 0 here, and y minus k is just y minus 0. So there's your vertex. Parabola opens left because it's a y squared type, so it's left or right, but you have the negative sign that's going to turn to the left. So this is the form. You have to identify the form. P is always positive, and this is the form it's in. So negative 4p has to equal the negative 8. Negative negative 4p equals negative 8. So p equals positive 2. Okay, so now we're going to come down here and mark that off. We got the vertex is 0, 0. We have opening to the left. So I'm just going to just lightly draw in here that's the orientation. That means the directrix is on the outside of the parabola. P equals 2. So 1, 2. Here is where the directrix is. And that's x equals 2, the directrix. And then inside the parabola, 1, 2 is the focus at negative 2, 0. Now I'm going to erase off my little guide there and try to get some points for real. So again, I'm not actually plotting points. I'm just going to do it by eyeball. I want to get a point over here that's equidistant from both of these. I'm seeing something like around here. Something where this distance was equal to this distance. That looks about right. So I'm just going to put a point there. And now I'm going to draw through the parabola. So I marked off a point in a similar location of this one over here due to symmetry. And then I drew the parabola through there, just real rough. And then there's your parabola. Then, add some fun here. The original equation is this. I took the plus or minus square root of both sides. See, we can't, it's not a function, it's just a relation. So you have to do two different y's to graph it. It's a plus one and the minus one over here. So really it's just graphing the top half on one of these y's and the bottom half on the other, but it looks all as one. And I think again that looks pretty good as to what we should get.